Hello, my name is John Bozard, and this is my Physics 2212 Lab 3 on the magnetic field of a bar magnet. The purpose of this experiment is to utilize a variety of physics concepts to analyze the relationship and values of distance dependence measurements in the magnetic field of a bar magnet. While following the procedure, I observed that when the magnetometer was at a far enough distance away from the magnet, the x component of its field was equal to 0 Tesla. In addition, I noticed that the distance between the magnetometer and magnet is inversely proportional to the magnitude of the magnetic field. Two primary equations used in this lab are the Biot-Savart law and distance dependence. The latter has two forms which will be used at different times throughout this lab. Here's my data for the experiment. The top left section are on-axis distance values that represent the space between the magnetometer and magnet when 20 microteslas are reached. 3 of these values are measured and averaged for different magnetic field magnitudes. The natural log of r and b sub x are then plotted for each condition to result in a line of best fit that can later be compared to a distance dependence formula. Finally, at the bottom are off-axis measurements for each of the components of the bar magnet's magnetic field. After entering the average perpendicular distance and calculating the corrected b sub y value, Excel returns a net magnetic field magnitude. Using a linear fit line from the previous graph, it can be seen that the n value is equal to negative 2.5428 and ln of k equal to negative 13.916. The reason the n value is not negative 3 can likely be attributed to the presence of nearby electrical equipment. However, for the purposes of the magnetic dipole moment calculation, n equals negative 3 can be used. First, I found k to be 9.044 times 10 to the negative 7th by utilizing log rules. Then I set the Biot-Savart law for a bar magnet equal to k times r to the nth power. Solving for mu gives a value of 4.52 amps meters squared. So, here's a quick run-through of my GlowScript code. In the top left is the magnetic field function, in which I define the magnitude and direction of r, as well as the Biot-Savart law. Next, I adjusted the scaling factors for the arrows and the zoom on the visual model, and also defined various observation locations. In the bottom left, I created 2 on-axis magnetic field arrows. Similarly, in the top right, I created 4 perpendicular axis magnetic field arrows. Lastly, I performed the same process for a magnetic field 45 degrees from the axis. If you would like to take a further look at this code, it's in the description of this video. From the visual model, you can see that the green and orange arrows represent the magnetic field on axis. The cyan arrows represent the perpendicular axis magnetic field, and the pink arrow represents the magnetic field at a 45-degree angle. The text box below provides the specific vector quantities for each object located in the model. What if I had not initially oriented my setup to account for magnetic north, but instead laid a meter stick at a random angle? Well, the results would be altered because I would be calculating the magnetic field of both the Earth and the bar magnet, so the x component on the magnetometer would not read 0 Tesla. Secondly, if I added an identical magnet to the experiment, I would find that a stronger magnetic field would exist, and the distances recorded would be smaller. Thank you for watching.